Myself is Dr. G. Venkat Subbareddy, Associate Professor of Triple Department, G. Polarity Engineering College, Kurnool. Today, will discuss about sag and tension in overhead transmission line. That is nothing but a mechanical design of overhead transmission line. What is the definition of sag? The difference in level between the points of support and the lowest point in the conductor is called sag. In case of sag, the shape is parabola or catenary. The difference in level between the supports, that is nothing but determine on the lowest point and the conductor is sag. S is nothing but sag, O is nothing but the lowest conductor, A and B and the two supports. A and B has two supports. The conductor is suspended between the two equal supports. Between equal supports A and B, D is the lowest point on the conductor, S is nothing but a sag in the sag. That is the vertical distance between the line joining the two point between the lowest point and the conductor is nothing but sag. When the conductor is suspended between the two supports at same level, it takes the shape of catenary. However, if the sag is very small as compared to span, the sag span curve is parabola. There are two shapes. One is nothing but a catenary, other one is nothing but a parabola. The tension at any point on the conductor acts as a tangentially. The tension at any point acts as tangentially. The tension T naught is the lowest point on the O, acts as horizontally as shown in the figure. The tension at any point on the conductor acts as a tangentially. The tension at the lowest point O is T naught, act as horizontally as shown in figure 2. The horizontal component of tension is constant throughout the length of the wire. The horizontal component of tension is constant throughout the length of the wire. The tension at support is approximately equal to the horizontal tension acting at any point on the wire or conductor. Thus, if T is the tension at the support of B, T is equal to T naught. Some important points regarding to the sag and tension. When same leveled two supports hold the conductor, bend the shape arises arises in the conductor. Sag is very small with respect to span of the conductor. Sag is very small as compared to the span. Span is nothing but the horizontal distance between the two supports. Sag span curve is like parabola. The tension at each point on the conductor act as tangentially. Again, horizontal component of the tension in the conductor is constant throughout the length throughout the conductor length. The tension at supports is nearly equal to the tension at any point on the conductor. How to calculate the sag? Sag calculation is classified into two conditions. One is when supports are at equal level. The second one is when supports are not at equal level, unequal level. When supports are at equal level, A and B has two conductors. O is nothing but the lowest point on the conductor. L is nothing but span length, the distance between the two horizontal conductors. Then at lowest point O, the tension is T. L is nothing but a span length. W is nothing weight of the conductor for meter length. W into x, weight of the conductor acting as a downward direction at a distance of O from x by 2. P at point P we consider the two coordinates x, y and y. Then at point x from the center of the conductor, there are two forces acting on this conductor. One force is downward in the direction. W into x is nothing but weight of the conductor acting in downward direction at a distance of x by 2. The x component is nothing at point P. The x component is x and y component is y. By applying the angular equilibrium at a point of P, x into y is equal to wx into x by 2. Then substitute x is equal to L by 2, then we derive the expression for sag in case of parabola method. Here, L is equal to length of the span, W is equal to weight per unit length of the conductor, T is the tension in the conductor. Consider a point on P on the conductor, taking the lowest point O as the origin, let the coordinates of P is equal to x and y. Let the coordinates of P is equal to xy. Assume that curvature is so small, the curved length is approximately equal to OP is equal to x. Suppose the curvature is very small, then OP length is approximately equal to x. There are two forces acting on the portion of OC and the conductor. The weight W into x of the conductor acting at a distance of x by 2 from the O. The conductor weight W into X acting at a distance of x by 2 from the downward direction, the tension T acting at pole. T into Y is equal to W into X by 2, Y is equal to W into X square divided by 2 pi, then the substitute X is equal to L by 2, Y is equal to S, then we get sag S is equal to omega L square divided by 8 into. In case of parabolic method, we consider two conditions, the equating the equilibrium. One is nothing but weight of the conductor acting at downward direction at the distance of x by 2. Then Wx into x by 2 is equal to the y component is x and x component is t into y is equal to t into y is equal to wx into x square by 2. Substitute x is equal to L by 2, then y becomes s. That is nothing but a sag. S is equal to w into x square divided by 8 into t. W is equal to weight of the conductor kg per meter. L is equal to length of the conductor span length. T is equal to tension in kg. In case of catenary method, in case of a conductor is suspended between two equal supports, then sag and tension calculations by catenary method, okay, here capital D is nothing but a sag. Capital D horizontal vertical distance between the line joining between the two support to the lowest point of the conductor. Here capital D is nothing but a sag. T naught is nothing but a horizontal component. At point of T, tension act as a tangentially. PQ is nothing but two supports. L is nothing but span length between the two conductors. Let the conductor is suspended between the two supports P and Q. L is nothing but a distance between the supports. W is nothing but a weight per unit length of the conductor or wire. T naught is a tension on the wire on the lowest point O. Assume the shape is catenary. Choose the axis OX and OS through O as shown in the figure. Through the axis and OX and OO, O is considered as a horizon, that is a lowest point on the conductor. The tension T acting at a point of A, let the conductor length is OA, that is equal to small s. Here in this diagram, the conductor length is equal to OA, the conductor length is OA, that is nothing but small s. This is nothing but A point. Let the conductor length is OA equals small, L is equal to length of the conductor. Total length of the conductor is L is equal to total length of the conductor. Consider the equilibrium of a small length S of the wire up to point A. This is XY. There are three forces acting on this wire. This is exact method. There are three forces acting on this wire. One is the horizontal tension T naught is W acting in downward direction. The vertical weight is W into S. The tension in T. We consider the true similar triangle from the above diagram. The coordinates of point A, comma A, x, comma y. Consider the length of ds. Consider the y is equal to ds. Consider a small length of dx. Its x-axis and y-axis components are dx and dy. Horizontal and vertical distances are dx and y as shown in the figure. T naught is nothing but horizontal component. W into S is nothing but weight of the conductor in downward direction. T naught is equal to tension. These two are two similar triangles. Then tan y is equal to dy by dx from this triangle. The same tan psi angle is same for two triangles. Tan psi is equal to omega s divided by t naught. Opposite side divided by adjacent side. Then from the Pythagoras theorem, ds square is equal to dx square plus dy square. ds by dx is equal to 1 plus dy by dx square. dy by dx is equal to tan pi and 1 plus tan square psi. That is equal to 1 plus omega x into t naught whole square, and ds by dx is equal to square root of 1 plus omega s divided by t naught whole square. Dx is equal to ds divided by square root of 1 plus omega s into t naught whole square. X is equal to integrating on both sides. X is equal to t naught by w sin h inverse of w into s is plus t naught plus c. If x is equal to 0, s is equal to 0 from this diagram, if x is equal to 0, if x is equal to 0, s is also equal to 0, then substitute here 0 is equal to t naught by w sin h inverse omega x by t plus c is equal to 0, then x is equal to t naught divided by w sin h inverse of omega s divided by t naught. Omega s by t naught is equal to sin h of omega s by t naught. From this equation 3, s is equal to t naught by omega, t naught by omega, t naught by omega, t naught by omega w in sin h of w into x divided by t naught. If x is equal to L by 2, capital S is equal to L by 2, length of the conductor, capital L is nothing but length of the conductor, S is equal to capital L by 2. Substitute here W L into 2T naught sin h of W into L square divided by 2T naught. Then capital L is equal to 2T naught into sin h of omega L. L is nothing but the length of the wire. But sin hx definition is x plus x cubed by 3 factorial plus x power 5 factorial up to dash dash dash. For neglecting the higher order terms, L is equal to 2T naught omega L by T naught square omega L by 2t whole cubed into 1 by 3 factorial and neglecting the higher order terms, finally we get capital L is equal to L into 1 plus W square L square divided by 24 T naught. L is nothing but a length of the wire. Then in this method, we calculate the total length of the conductor. Small l is nothing but a span length, W is weight of the conductor, T is tension in the conductor. From equation 1 and 2, dy by dx is equal to tan psi, that is equal to omega x by d naught. Then substitute here dy by dx is equal to omega x t naught by sin h. Dy is equal to sin h is inverse of omega x by t naught into dx. Y is equal to integral of sin h of omega x divided by t naught into dx. Y is equal to t naught by W cos h of omega W x into t naught plus c. At x is equal to 0 and y is equal to 0, then c is equal to minus t naught by w. Substitute in this formula, then y is equal to t naught by w cos h of omega x divided by t naught minus t naught by w. Omega t naught by w is equal to common sin cos h of omega x minus 1. From the definition of cos h x is equal to 1 plus x square by 2 factorial x power 4 by 4 factorial. By neglecting the higher order terms, y is equal to t naught by w 1 plus w into x square divided 2 n square 1 1 get cancelled. Y is equal to t naught by w x square divided by 2 t naught whole square. Y is equal to wx square divided by 2 t naught. Substitute x is equal to L by 2, y is equal to capital D, that is nothing but a sag. Capital D is equal to w by 2 t naught into L square by 2, w L square by 8 t naught. D is nothing but a sag, that is equal to w into L square divided by 8 t naught. Sag at point A, d minus y, omega L square by 8 t naught minus omega x square by 2 t naught, omega w divided by 8 t naught into L square minus 4x. Again from the triangle, t is equal to square root of t naught square plus omega s whole square. Plus in the previous expression, omega s by t naught is equal to sin h of omega s divided by t naught. Then the t naught square is equal to t naught square plus omega x square from the right angle triangle. T naught square plus t naught square sin h square omega x by t naught. T is equal to t naught square into 1 plus sin h square into omega x by t naught. T naught square is equal to 1 plus sin h square is equal to cos h square. Then substituting here cos h square value, then 1 plus omega x square by del. The tension at any point is equal to T naught into 1 plus W square into x square divided by 2 T naught square. That is nothing but the tension in the conductor. If x is equal to L by 2, at the junction at point Q is equal to TQ, at the support of Q is equal to TQ, then TQ is equal to T naught plus W square into L by 2 whole square divided by 2 T naught. TQ is equal to T naught plus W into W square L square divided by 8 T naught. TQ is equal to T naught into W into W L square by 8 T naught. That is nothing but a sag D. Then TQ is equal to T naught plus omega W into W into D. D is nothing but sag T naught is nothing but tension at the lowest point. It is the exact formula for tension at any support. Tension at any support is equal to tension at the lowest point plus weight of the conductor into sag. This is the exact formula. In this derivation, we calculate three formulas. One for length of the conductor capital L. The second one is a sag capital D. The third one is a tension at any support TQ or TP is equal to T naught plus W into D. This is nothing but a normal condition. There is no ice and wind effect. There is no ice and wind effect. That is a normal formula for sag when two supports are equal heights. While considering the effect of wind and ice co-loading, while considering the effect of wind and ice co-loading, the ice can be act as a downward direction as the weight of the conductor, and wind force is horizontal direction. W plus W is equal to weight of the conductor in the downward direction. WW is equal to wind force. The resultant of the vector is equal to WT, that is nothing but equivalent weight of the conductor. In actual practice, a conductor may have ice coating and simultaneously subjected to wind pressure. The weight of the ice vertically downwards, that is in the same direction as that of the weight of the conductor. The force due to the wind is assumed to be acts as horizontally. at right angle to the projected surface of the conductor. Hence, the total force on the conductor is vector sum of the horizontal and vertical forces. The total weight of the conductor is equal to the vertical sum of horizontal and vertical distances. Total weight of the conductor for unit length WL is equal to W plus WI whole square plus WW square. The weight of the conductor for unit length, weight is nothing but conductor material density into volume of the length. This is a formula weight. Conductor density into volume is nothing but weight. Wi is equal to weight of the ice per unit length, density of ice into volume per unit length density of ice into pi by 4 d plus t whole square minus pi by square is equal to area into length is 1. Density of ice into pi t plus d plus t. Then WW is equal to wind force. Wind force is equal to wind pressure of unit area, projected area of unit length. Wind pressure into d plus 2t. This is nothing but projected area for unit length. Wind to wind pressure is equal to WW. After getting the weight of the WI, wind force, then equivalent weight of the conductor is WAT is equal to W plus WI plus WW whole square. That is nothing but total weight of the conductor. Then after getting the weight of the conductor, then sag is equal to omega t into L square divided by 8 into 3 is nothing but sag. When the conductor has a wind and ice loading, the following point. The conductor set itself a plane angle of theta, the vertical plane tan theta is equal to WW plus WWI. The sag is nothing but S is equal to W into L square by dt. The vertical sag is nothing but S cos theta. Tan theta is equal to, from this phasor diagram, tan theta is equal to WW divided by W plus WI. From that tan theta, we calculate the cos theta. S into cos theta is nothing but vertical sag. If any problem, there is asked vertical sag, the formula is S cos theta. S is nothing but a sag. Cos theta is calculated from the phasor diagram. That is nothing but a two supports at equal height. There are two methods. One is a parabolic method. The another one is a catenary method. Catenary method is nothing but exact method. In this method, we calculated three parameters. One is the length of the conductor. Another one is a sag. Another one is a tension at any support. When supports are at unequal levels, a conductor is suspended to the river crossing whatever area, two are unequal heights. One is nothing but conductor pole A, this is pole, but lowest point is not a midpoint. Lowest point is not a midpoint in case of two supports are unequal level. Then Hy is x1 is equal to the distance of lowest point from the tower A. X2 is equal to the distance of lowest point from tower B. L is nothing but a span length. S1 is nothing but sag at lowest point. S2 is nothing but sag at highest point. H is nothing but a level difference, then that is equal to S2 minus S1. This is nothing but a when two supports are at unequal heights. In hilly areas, we generally come across the conductor is suspended between the two supports at unequal levels. The figure shows the conductor is suspended between the two supports on A and B, which are at different levels. Which are at different levels. The lowest point on the conductor is O. L is nothing but a span length. H is nothing but a difference in level between the two supports. X1 is the distance of support at lower end from O. X2 is the distance of support from higher level of O. T is nothing but tension in the conductor. Then weight W is equal to weight per unit length of the conductor. Then sag S1 is equal to W into x1 square divided by 2t. Sag S2 is equal to W into x square divided by 2t. X1 plus x2 is equal to L. S2 minus S1 is equal to W by 2t. X2 square minus x1 square. W by 2t. X2 plus x1 into x2 minus x1. X2 plus x1 is equal to L. Substitute here S2 minus x1 is equal to WL square divided by 2t and x2 minus x1. Then S2 minus h1 is equal to level difference. H is equal to W into L into divided by 2t. From this expression, calculate x2 minus x1. To solve these two equations, then we get x1 value and x2 value. X1 is equal to L by 2 minus TH divided by W into L. X2 is equal to L by 2 plus TH divided by W. After getting the S1 and the S2 value, then S1 and S2 sag is easily calculated. Here important point is lowest point on the conductor is not a midpoint. In case of when the two levels are unequal support. Stop here.